Okay, so in the last class we studied about layered architecture. So we'll continue our discussion on that. And since you guys have not done, many of you have not done course on networking, so it's important that first you understand the concepts of networks or internet, and then we'll learn about security aspects of different parts of network or internet. Okay, so today we'll take up this topic on physical layer. Okay, so we'll study about physical layer. We'll look at what kind of security we need, and then we'll, if time permits, we'll look at link layer or layer 2. Physical layer is called layer 1, and then this physical layer. Layer 2 is data link layer or link layer. Okay. All right. So these are the topics we'll cover. Before that, just I want to start having some discussions about what do we learn from security concepts, because whatever basic principles we have learned in the course we apply to our life also, because we also need to secure. Okay, so one way of, so whenever there is a virus or malware in a system, the system's behavior changes, right? So behavior is a way that one can find out that there is an issue in the system, right? Or there may be malware. Okay, so behavior based detection, intrusion detection is one of the important techniques. How do you, now the important thing is behavior, right? Why does behavior change? It's not the normal behavior, right? The way you design system to behave. Okay, it changes. Because, say malware starts consuming resources and so on. All right. So coming back that to the point that behavior is nowadays, behavior is very important for virus to detect, because every malware or something will have some signature. Okay, and behavior. So these are the 2 points. Based on that, we can find out if there is an issue or not in a system, or there is a malware or something, right? Because system behaves differently. Okay. How about your behavior? To me, this is the most important thing in life, the most important. You will get job. Once you get a job, your progress from a software engineer to CEO of a company or CTO of a company, okay, happens primarily because your behavior, nothing else. In the beginning, of course, there's your technical competencies matter, but even then, even first to second level promotion which I have given, or from somebody who is director to vice president level, it happens because of how person behaves. So behavior is external manifestation of what you are internal, right? Internally, so you get an stimuli, and then how do you respond to that stimuli or input? That's your behavior. So all I want to say is that to me is the most important thing, and then a question to you is how you change your behavior. How do you change your behavior? First thing, observation, and then how can you change your internal state? If your internal state is right, then only then because stimuli will go to your internal state, and then it will result in response, which is your behavior. So you'll have to change your internal state. How do you change your internal state? Start thinking about it. Okay. All right. Otherwise, you cannot change your behavior. First, you'll have to think. Just think about it. What can you do? All right. So this is what we studied in last class. Okay, IP, this is an internet architecture, right? and it's also called narrow waist. Largely because below IP and above IP, there are multiple protocols, right? But IP is the most important thing, and all other protocols are based on IP. Or I should say, all up on top uses IP, and IP uses something below, right? So IP is essentially interconnect layer. Okay, so these technologies existed earlier also in some form or other, not necessarily 5G kind, but now IP is influencing lower layers now. Okay, like we have 5G, 4G, etc., or we have fiber, etc. But IP does not depend on that. So these two layers, physical layer and data link layer, provide a path, a link, right? Okay, they just form a link or set of links within a subdomain. We also call this a local area network. We also call this a simple link. If you want, you can treat this as a link in same IP subdomain. Okay, all right, we'll come to these concepts later. So it's a narrow ways. Just remember this diagram that IP, when you say what is so good about IP, you say that the IP is the protocol that it must support. Okay, what is the essential component of internet? You say is just nothing but IP protocol, right? On top or that, UDP and TCP are two important protocols, but you can always design, or in future there will be more protocols that will come in. Okay, but IP will remain same because that is the basis of internet. Okay, technology below will continue to change. Now we cellular, we have 5G, we have Wi-Fi. Within Wi-Fi, we have various technologies are coming in with more and more speed. We can have also broadband wireless. Okay. Similarly, Ethernet is also changing. Now I have fiber-based Ethernet, which can switch at transmit at gigabits per second, Gbps, right? And so on and so forth. So layer below will change as technology changes. Layer above, one can always design. Now app layer, of course, anybody can design this. Okay, and of course your applications are of different level altogether. You can design any app. So something that remains constant is essentially IP. Okay, so remember this. It's another diagram. Okay, only at the end, note that internet is best effort delivery mechanism. Okay, it does not guarantee you anything, right? So now it is a responsibility of end machines to provide reliability. Okay, can you please mute your mic? Okay.
और इशू कहाँ गई आज बताओ इशू कहाँ गई आज कहाँ गई है इशू कहीं नहीं गई इशू है ना
There is someone who's speaking, possibly at home. All right. So remember this thing that applications run in internet, whatever be number of, now we have shown only one router. This could be, suppose your laptop is connected here and running your app. This path could be any long, right? These are all the routers in between, this end machine, and then server is connected here. All through this part, excepting at the end, you will run these three layers. The responsibility of internet in between or connected routers that forms a path is just to transmit your packet. Okay, for that you need only layer, physical layer or link, on which it will go either wire or wireless. Then the protocols, how you will form the packet and how packet will access this and all that, right? Such that packet reaches to other end. and the network layer which is responsible for defining what the IP is, IP what, okay, and then how this will be routed. See, the routing becomes important for packet. So now all these places, you know, the aim is just to route the packet, IP packet that has come in. Okay, and remember one more thing which we discussed in the last class is that let's assume that here application generates some data. Okay, like right now what we are doing now on we are using some voice or IP application that's built in WebEx. Okay, okay, and that this application goes inside my TCP packet, right? Now TCP has features for reliability, retransmission, etc. And it also has some other things we'll study, right? And now packet comes, this packet is here. Okay, now that goes inside IP. So that's put inside IP packet. Only IP packet will have end destination address. One of the fields here will be end destination address corresponding to this. Okay, and then so now we have this net that we have seen. Okay, now it goes to first link. Now this first link could be Wi-Fi. Okay, then this IP packet must be put inside another one, another packet which is corresponding to Wi-Fi, which we call this outer packet we call as frame. Okay, now this packet will go only up to this point. Okay, then because this outer packet corresponding to layer 2 is only for Wi-Fi, and then this packet is taken out, outer packet is taken out, and what is left out is nothing but something inside, that is IP packet and carrying TCP packet, this IP carrying TCP, TCP carrying your data, our data, right? So this IP is taken out, and then network will see what is the next link. Next link happens to be fiber. Then it will put inside another packet, layer 2 packet, sorry, layer 2 packet, and then it will be sent here. The destination address for this layer 2 packet will be this node. Similarly, destination address for here for layer 2 packet would be the node here or port here. Okay, in this way packet goes link by link until it reaches end, and end application will look at, take out the IP packet, from IP packet will take out transport packet, will check if everything is all right. If not, then it will request for retransmission of the packet. Okay, all this happens end to end. In between, network is not bothered at all about reliability or any security. All right, remember this thing. Any question? Yes or no?
No, sir.
Okay. All right, so we have spent quite some time about it. So now we have this kind of architecture, right? We have physical layer, data link layer, network layer, transport layer. These two layers are not there in internet, and then app layer. Well, correspondingly, we have physical link, we have MAC address or layer 2 addresses, which we'll study later, IP address corresponding to network. Now this has to be unique all across the world, right? That defines how your packet goes. And then protocols and ports like TCP, UDP, and then port defines nothing but which application is using. Now, for example, your packet reaches a destination server, but there are multiple applications running out there. So packet has to go to appropriate application, right? So now here the packet goes to, for example, TCP. For TCP there is a different port, then sorry, for HTTP there is a different port, and for other, a lot of applications can run, and then it may go to different ports. Okay, all right. So this is how it happens. Now the problem is that how do you provide security in this case? Where do you provide? Do you provide physical layer, data link layer, network layer, transport layer? or application layer? Okay, the answer is that you have to provide at all layers. Okay, because if one layer is hacked, other layers are not aware of the hack, right? Because the way it's a design, there is only one interface through which data link layer communicates with physical layer and so on, right? So if so interface remain intact. So but what is happening here is not visible to layer above. Okay, that's how because what we have done is a modularization, is a module, and module is a for data link layer everything is black box. What is happening here, excepting for interface or APIs. Okay, so now see if anything is compromised, then everything above that is also compromised. Okay, and the weakest layers are layer 1 and layer 2. Like we'll spend time on that, right? So first layer is physical layer. Physical layer is nothing but this wire, like cables, right, which we call in networking cables. Like we can have STP, shielded to state pair cable, UTP, unshielded to state pair cable, fiber cable, and so on and so forth, right? Or it could be Wi-Fi, okay, which is nothing but air as a medium, right? So now how do we provide security? And physical layer's responsibility is that putting signals, right? First thing is that so higher layers are giving nothing but zeros and ones, right? Combination of zeros. How do you change the zeros and ones to voltages? Or in case of fiber, light, there's light or no light. Okay, in case of radio, this has to be changed into radio waves. All right. So now the responsibility of physical layer is to provide that medium, like cable, etc., or fiber, and then putting signal onto that medium, and then on the other hand making sure that it's received, right, or is given to high level after receiving, right? So this physical layer we see is the lowest one. It provides sending bits from one device to another, or one, if this is the link, right, and this is a medium, say copper for example. Okay, how do you put signals here? What should be signal level of signal, half volt, 1 volt, 5 volt, or whatever? What should be gap between two signals, and how do you do coding, right? There are a lot of codings are available. Of course we don't want to get into that aspect. All right, so all this is taken care of, right? Like the physical layer says that how do I transmit sequence of zeros ones from one device to other device? That's the responsibility. Okay, for example, is this cable is bad quality by design, by cheaper quality, then maybe you'll have to put signals of higher strength at some gap, right? In between two signals, there should be some gap, possibly to take care of inductance or capacitance or whatever. All right. So how do you provide security for a wire that's running? And is it important? It's most important thing, right? Because network consists of devices and communication link. If somebody steals your device, right, then whatever security you have at layer 2 or TCP layer or IP layer is all gone, right? Similarly, if somebody is able to interrupt your communication by cutting the wire, then you can't do much, right? So there are physical threats to devices and links, and we know all this: vandalism, lighting, fire, somebody pulling the cable, okay, excessive pull forces, corrosion, wildlife, and all that, wiretapping, crosstalk, jamming. All these are the methods that whatever you are communicating can be disrupted. Okay, and of course, especially in India, there are a lot of monkeys are around, rats are around, and they like to play with cables, right? So they can also disrupt. And then there, there are lot of cases where you can see the physical cables have been stolen or cables have been cut and so on and so forth, right? And then, okay, good thing is that fiber is inexpensive compared to cable, so thieves are not so much interested in stealing fiber cable. But when somebody wants to disrupt for some reason, okay, then it's very easy. And you can find plenty of stories, right? That somebody has stolen copper wire, somebody has stolen the equipments and so on. Now, this is very common method that happens in offices. Okay, some people keep whatever their password etc. on a small notice board or on their desk. It can be stolen. Then people leave all the information on the notebooks etc. or throw it in the dustbin. All these are collected. Remember, all these are collected. That's the reason there is a kind of cutting machines are there in office, right? So before discarding any paper, that's important to cut it. Okay, so all this which you say recycle bin etc. all most of the places, even government offices, these are bought by professional thieves. Okay, make sure that whatever when you join job, make sure that you don't leave any information anywhere, right? And all these are very very important, like even your like credit card details, IDs, passport numbers, source code etc., right? All these are very very important. So for example, for source code, you take a printout and leave the printout, you think who will take care of it and throw it in dustbin, but it has a lot of value for it can be sold, and it has been selling. Okay, shoulder surfing is another one where you're doing something, somebody comes behind and notes down your password etc. And one of the cases which is very important, which you should look at, is intimate partner threat, right? So your intimate partner, your spouse, your girlfriend, boyfriend, whatever, if you reveal all the information, it could be very dangerous. Even you know even there are a lot of cases, right? And possibly look around, you'll find many. So okay, so intimate partner threats is happening for a very long time now. It has taken, now people know about it. So if you're sharing everything to his, including a password, your salary details, your whatever you think confidential to your intimate partner, could be your spouse, could be your whatever. Okay, it could be your siblings. Think if it's not necessary, then don't do it. Okay, another way of disrupting the normal activities or normal communication that goes on in a city is just you need to buy just scissor like this and cut the cable. And see, cables are everywhere. If you look around in big cities in India, especially in India like Bangalore, you can, if you want, you can just steal, not only disrupt by cutting cables, but also you can steal the data very easily by putting some kind of tap here. Okay, so this is how things are here. Okay, so many of these are all fiber cables. Some could be video also, but largely fiber. Other way of stealing information is through noise or information leakage. You must have seen that when you would have studied, right? A conductor carries current, then you have magnetic field around it, and then if you tap this, or you can read this by putting some device, right? So that's also possible. Okay, physical tapping is your cable, especially thick Ethernet kind, which of course is not in picture nowadays, but a cable carrying data, you can possibly put a small tap here, conductive tap, and get the data out. And also there are inductive taps, right? So I mean, inductive taps essentially if there is a EM radiation or EM induction. Okay, please read it by yourself, and we're not going to go into it. There's a case study which you also should read. It's about submarine cable called IV bells. So USSR, or former Russia, has undersea cable that connected Soviet naval base to some places, and now it's undersea, right? So US Navy and joint US Navy and CIA operation have put a tap on the cable. This was obviously a copper cable or metal cable, right? So there is an induction around it, right? Now, if Americans cut this off and put a device here in between, then Russians will come to know. So what they have done is they have put a small device around it, and that will store signals for a month or something. Every month, some divers will go there and collect that data, right, through induction. It happened for few decades, I think 2 decades or something. And so there's another way that all the data that's going through a cable, just by cable tapping operation, they could collect all the data. Okay, all right. Any question? So insider threat, I mean, when we studied kind of, remember in second or third lecture, sometimes we studied about different threats, and we have looked at the patterns, where a lot of information goes off, and who can give a threat to a corporation. A significant portion of that, in the order of 20-30% something, to a corporate is insider threat. And people who are inside the organization know much more than people outside, and they can provide threat, because not everybody is honest, right? Not everybody is ethical. Some people are curious, some people want to disrupt the operation, right? Okay, so it could be individuals like your current employees, okay, or the past employees, full-time employees, part-time employees, temporary workers, contractors, or trusted business partner, because no business operates off its own, so it has a lot of partners, right? And they are also given access to organization, right? So they can also pass information. What are the assets of organization? The people, knowledge of the people, then information, technology, facilities, right? These are assets. I mean, for example, for Google, it's not only employee but the code base. Okay, now what can be done? A lot of things can be done. People can be threatened, then people can be pushed to reveal something which is IPR of a company, or it can be, code can be stolen. There can be workplace violence, and a lot of things. Social engineering, through social engineering, people can come to know a lot of things, and so on, so right. And that impacts the organization in many ways. Reputation of company goes down if internal employee hacks the company, and then people come to know about it. There's a lot of damages, right? Internal employee steals the code. That's very, very common, right? I mean, many organizations allow employees to see the complete code base. Note that whatever you do in any organization is not your property. You're not supposed to bring it home. They are paying you to develop something, so it's the organization's property, right? But many employees do steal, and when they leave company or in between, they copy the whole source code. I don't know, for some reason, and from there it's either they sell it off or it's stolen or something like that, right? So you can see a lot of in darknet, you can see a lot of source code available. It's not so, all these things are possible if there is an insider threat. So organization must not only provide protection to itself with external things, because in organization normally people think the external forces, right, can disrupt, but they are an insider who can. So insiders are more dangerous because nobody suspects them. They will do what happens, right? So organizations must protect themselves, right? So for example, when you join an organization and you are using organization's resource like email for personal use, right? You're sending it to some non-organization address. Make sure that is 100% being checked, not manually but through machines, that it does not contain any confidential information, right? So all these things happen. Okay. So physical level security is that it, I mean, the way we provide security, in any organization. I mean, when you enter organization, and not anybody can enter organization, right? So there's access control. Then once you go in, you are given login. There's a multiple levels, like there are security cameras and so on and so forth, right? So all that is done to create physical security. For example, you'll find that there are a lot of routers sitting around, right, in a company. And routers have a lot of ports. Can you connect your laptop to a router? You're not supposed to connect, right? But if the port is available and there's no security here, then you can connect and then do things, right? So usually you have also in any organization not only system level security but also physical security, like cameras or security guards or other set of employees who are watching you and so on and so forth, right? Okay. All right. So one of the very common ways that of course gates, guards, etc. This we know. Employment checks happen, right? Your background check. Most organization pays to third party something around 20,000 rupees to check your background, right? Which companies you have worked. Actually, you have worked. Do you have actual genuine degree? Did you fake your marks? And all that things are checked. And I have given contract to a third party, and we find that about 5% employees have faked their degree. They were sacked, right? At least twice I have done this in my career. Okay. And then, when you log into a machine and if session is inactive, then it will log you out, right? So these kind of mechanisms are built into the system. All right. Mobile devices and media, there's a lot of discussions about it. Can you carry earlier, just 10 years back, mobiles were not allowed in offices, 15 years back, because you could take photographs and you can do that. Now, something called mobile device management is there. Many companies do this, mobile device management. So every mobile device have a software where how device will behave is controlled by a third party. Okay. Like organization. So organization has control over all the devices that are coming to the company. And then they can check and they can also restrict. For example, during 9 a.m. to 5 p.m. when an employee enters organization, the employee cannot take photographs inside, right? Something like that. Okay, so my group in Nokia had developed this software, and every device has it. There's nothing unique about it. All right. Laptop security is very important. Even within organizations, their laptop locks are given. I mean, there's actually physical lock. Like, if you earlier, and 20 years back when you used to travel in third class sleeper on trains, then we used to carry a chain and a lock, right? So the suitcases are not stolen, right? You just lock. Similarly, in organization, this chain and locks are given, right? And so, and big companies say that when you're traveling, then make sure that laptop is your responsibility. It's not that cost of the laptop, but something that is inside that is very important. Okay. So when whatever organization you join, make sure that if your laptop is stolen, then this issue goes up to CEO level. And it goes against you. All right. Does this? I have taken this photograph some time back, just about a week back, in one of the ATM machines. Does this provide any security? This physical security to ATM machine, does it? Anybody?
No, sir.
Yeah. Of course, objective is lost. If the person is sleeping, but of course, nobody will steal ATM machine. So there's some degree of security, right? If you put in front of you an independent house or villa, If put in front of that, you know, is you know, there is a camera. What is, you know, you are being watched, or there's a dog. You know, beware of dogs and so on. So obviously, you know, thieves will think twice before entering your house, right? So even this kind of security helps in some degree of security, but not fully. All right. So this we have already covered now. So basically, physical security is very, very important because a lot of cyber threats happen because of physical security, physical equipment, the cables and any equipments not being protected, right? While your laptop may be doing encryption, what happens if laptop itself is stolen or cable is cut, or you know, cable is tapped, right? So all these threats can be very serious. Okay, and all these threats, it does not require any expertise in digital technology, right? So and examples are given here, and they can be very dangerous. So organizations or individuals need to protect from these kind of threats. Okay, all right. Now let's come to layer 2. Any question up to this point?
No, sir.
All right. So in this diagram, where are the links? So we use this diagram, you know, like this for routers. Okay. Where are the links here? This is a cloud or ISP. This is a ISP provided network where you will see only routers, right? Interconnected to each other. And of course, from routers, the links may go to some point, somewhere or other, right? Okay. Where are the links? These are all the links. This is a link, the link here, link here, link here. This is also a link. Okay. Now, when we say layer 2 technology or link layer technology, so we may also include a LAN. Okay, we'll study LAN in the next class, right? So in LAN, we have to send packet from one node to another node. So inside it could be any number of nodes. Okay, but they all operate at level 2, layer 2. Right? So there's no use of IP for packet transmission inside a LAN. Okay, remember this point. Okay, all right. So we'll come to LAN little later, but LAN is layer 2 technology, right? Within a LAN, one machine can communicate to other machine without going through IP protocol. Like, you know, in your, even your mother is sending laddu to you in a hostel, she will use IP, okay, or unique address that you have. But if your next room, the friend who is in next room does not require IP address, right? You'll just go on chit chat, right? Or pass on things just like that, right? So similarly within a LAN, you don't need, you know, this IP address. Okay, we'll come to that point later. Now these are the links, like, you know, Ethernet cable. This also Ethernet fiber. This Sonnet is another technology. It's older technology. It works on fiber. Ethernet fiber. This is a satellite link. Now you have ADSL cable, DSL or ADSL. You know, basically creating communication channel over telephone link, right? Okay, you have Wi-Fi, you have cellular, you know, 4G or 5G and so on, right? So these are all linked. Okay. Now the responsibility of link layer protocol is how do you communicate data uh, data from one end to another end, because each cable is of different type. I mean, it could be of different, could be Wi-Fi. So there's no cable here. There is only air, right? Now, if this link happens to be fiber, then this is a vacuum, right? All right, it's just glass in. nothing more than that, right? Okay, if it's a satellite, then your signal will go thousands of kilometers up where the satellite is and comes back. Now this channel is very different. Okay, then how do you put sequence of bits onto that? How do you, and how do you know at the other end it has reached properly? Okay, now if you want, you may also want reliability here, or or sequence in which packet will be received. So all these things you need to do. First thing first is that how do you access this channel? Okay, and how do you access this channel? How do you, there are for example, there's a Wi-Fi, multiple people are trying to use the same air or same frequency, set of frequencies. Then how do you get access to that? That's the first point, access. Then second is that once you have gone in there, once you have achieved the access point, or you are able to uh, transmit, then what rate you need to transmit the signal? All these things will come in here in link layer technology, right? Okay, and there are various kind of links for home connection, like dial-up, like normal PSTN. You use modem, convert digital signal to analog signal. Analog signal will go over PSTN dabba, old time dabba, and then will receive and convert into digital signal. Then ISDN came in, DSL that we discussed earlier, cable TV was used, fiber to home, which is most popular now. Okay, apart from them, we have Ethernet, Wi-Fi, cellular. Okay, if you see this kind of dabbas, boxes, then this kind of boxes, these are all Ethernet ports, layer 2 devices, right? And layer 2 devices, we call it switches. Now, if switches work on layer 2, and on top, if this dabba also contains routing software, then we'll call it router. So router will have a built-in switch inside. Okay, normally what we get here, like Linksys 1, or like Airtel gives you a box, is nothing but a router. All right, and then we have like this cable used to connect earlier. Nowadays, of course, you have Wi-Fi. Okay, it's Ethernet cable, right? Like this kind of cable you would have seen. So what is the function of link layer? Now let's come back to this layered model. So now note that link layer and physical layer are implemented at all the nodes in the internet. All right. So this is implemented. These three, link layer, physical layer, and network layer, are implemented all over. Okay, we have seen a diagram also, right? And at the end, we have transport and application layer, right? So this already we have discussed. Now, note that link layer and physical layer for each hop is different, right? So this could be Wi-Fi, this could be fiber, this could be Ethernet, fourth could be satellite. So this link property is different. And then how do you put the bits into a frame and send the frame across? So protocol for that has to be different, right? For example, we are sending it to satellite. Satellite, it will take a lot of time for your signal to reach to satellite, and there are a lot of a lot of errors may be there, because because of lot of in between your packet may meet with some electromagnetic disturbances, etc., right? So then you have to code the packet differently. You have to focus more on error correction and detection and so on, right? All right. Okay, so these two are different for each hop. Okay, because the physical layer is different. Hence, how do you put the packet or data onto that, and what kind of protocols you use has got to be different. So we will see this diagram very often, that you can see link layer and network layer, and also physical layer is not shown here, something like here. Okay, so you can see these three layers: physical layer, link layer, network layer, common across, and only at the end you have transport and application layer. So now as the packet comes from here, you have some data it comes here, it gets encapsulated like this. Okay, so you have actual data, application data, it could be anything. Then you have transport layer header. So now this becomes transport layer packet. This contain actual data, and this will be header, which will define ports and sequence number and all that things, right, of the packet. And then this becomes IP. It will define source IP address, destination IP address, and so on and so forth, right? And all this packet, okay, is meant for end-to-end hopping, right? Okay, so this remains same until it reaches to the end. But something that changes from link to link, this is put inside a box which is link layer packet, and then this changes, this outer envelope or packet changes at every hop. Okay, like your mother sends you laddus, put in a packet and then write your name, and that dabba will reach you to the end. But in between, when it goes on cycle, guy will put this on another dabba and write the address of some local guy there, right, where courier guy. From there it goes to another courier office, and then this goes over years and comes, they will put this under another box and so on and so forth. So in that box, the address, outer box address is again to some hub, right? And from there is removed and then again put into next box, and then that way it goes, right? Similarly, link layer packet keeps changing, that outer packet, but inside one remains intact, right? So this one, when it goes to next link, will remain as it is, and then depending on link, you will change the outer packet. Is it clear to you? Okay. All right. So what we have discussed is here. Okay. So when A is communicating with host D, we'll have to look at what this is a path, for example. Then we'll have to see, and there are different links. There will be different link layer protocol. It means that this link layer packets will change at each hop, while the contents of that, only header will change, contents remains the same until content, maybe IP packet, will remain the same till the end, like your mother's laddu packet. Okay, and content in the laddu packet is laddus, right? So the content that's being sent on TCP will reach here, but each hop you'll see that changes, right? Outer packet changes, right? So link layer protocol here is responsible for transmission of packet from one end to another, and so on here, and so on here. So a packet comes here, it will remove IP packet, then put it inside a layer 2 packet here, depending on what layer 2 is. When this packet reaches here, it will remove this thing, this outer packet, take the inside one, and then put another packet until it reaches the other end. Okay, all right. Right. So now you can say that layer 2 provides framing and transmission of collection of bits into individual messages. So it will create a frame. Now it receives IP packet, right? For example, it could be anything. It receives IP packet. It will put into this part, and this is the header. Okay. So header will contain source address, destination address. Now it will also have some characteristics like, how do synchronize clock when packet reaches to other end, right? So some extra signals are also there, and also something, some bits have gone bad, so it may have CRC, cyclic redundancy check, or error correcting codes, and so on and so forth, right? All right. So link layer data is encapsulated in link layer frame. Okay, and the protocol that we use is in general called medium access control. Okay, we'll come to this terminology when we study Ethernet. The next lecture, we are going to look at Ethernet. Okay, Now, when LAN is technology started, early 80s, there was something called token ring. The whole idea is that there are nodes within an organization or home that needs to be connected. Okay, so what is simple way of connecting? Most simple way of connecting them is to connect them in the form of ring. So if this guy, say A, has to send message to D, okay, it will create a packet, right, source address and destination address, and send. Now this guy can communicate only when it has a token. So there must be way to generate token, and then the one who has a token can communicate. Okay, then when this guy has token, it will create a message, will send the message, and each node in between will see whether the message is for itself, whether it's forward until it reaches the point here. Okay, this was a kind of early technologies, right? Then came few other like token bus, etc., right? And these were all the problematic technologies, right? Because if this cable is disrupted or cut, then whole communication will break, and then who will have token will also require some kind of election mechanism, right? Voting mechanism, and there will be some supervisor, and all those concepts are there, right? How token will go into next node, and so on and so forth, right? So it was kind of complex technology. And now we have something called Ethernet. Ethernet is protocol that we are using right now in the class. Okay, medium is that this communication medium that we have. Now, what is the simple rule that we are following? If there is a silence, then anybody can speak, right? I am speaking because there is silence on this channel. If you are speaking, if there is silence, you start speaking, then you will continue to speak. Okay, if two of us start speaking, then we'll find that there is a collision. So both of us will back off, and then when there is a silence, then one of us will start. Okay, so this was Matt Cafe's original diagram when he designed this. Say that nodes can be connected like this on the cable, and when there is silence in the cable, then any node can transmit. Okay, and it reaches to other end if there is a and signal comes back, then it knows that there is no collision. Otherwise, they can find out there is a collision, right? It's a mechanism is there to find out collision. If there is a collision, then everyone will stop, and after random time they will again start communication. That's as simple as that. The original Ethernet, right, is called CSMA-CD. Carrier sense, you sense the channel is empty, then start communication, right? Carriers and multiple access, multiple users can sense this channel. Okay, and when two people simultaneously starts communication, then detect that there is a collision, and then everyone stops communication. After some time they will try again with some probability. As simple as that. Very simple protocol, unlike this complex protocol who will go next and so on and so forth, right? Okay, and it has become the dominant technology over last 4 decades. It's the only technology because all that has is a Ethernet frame or packet format. Okay, we'll look at that in next class. And now the technology is improving, like we have terabit Ethernet with fiber. So same technology goes on, so it provides scalability. Okay, all right. Okay, to summarize, we have looked at physical layer security, and we have seen physical layer security is very important. A physical layer consists of devices and links, physically in the sense of metal and so on, and then make sure that all these are protected. And then we'll start looking at Ethernet technologies, right, or layer 2 technologies. Okay, any question? No? Shall we stop? Okay.
Hello.
Yeah.
Yes, sir. I had a doubt regarding the assignment.
Yeah.
Sir, in that Ubuntu 20 image was specified, which is 64-bit, so there was issue setting it up for 32-bit. So can we use Ubuntu 16 for it?
So read the instruction that is given.
Yes, sir.
Which
I've tried it and
buffer
done it on
overflow,
16.
right? Buffer overflow problem is designed for a lab, and lab whole thing is designed on a particular version of Ubuntu.
Sir,
You just
it's
need
working
to,
on 16 as well. I
whatever is
did it on.
defined, because they have disabled, address space randomizer and many other things. Even latest Ubuntu takes care of some of these issues. Okay, buffer issue. They would have canaries or address space randomizer, etc. So I'm happy first thing that you are doing it. Just follow instructions that's given in the book, and I have sent you the chapter. Okay, just follow instruction, you will get it. If you search internet, you will also get a solution of that. All you need to do is dirty your hands. If you use the latest version, then you will not be able to get buffer overflow. Okay, just follow. Okay, all right. Any other question? Okay, I need 5 extra hours from your class for next whatever 1 month left out, right? Because if you want to learn about something like crypto or blockchain, then I need 2 extra hours, and then we are going very slow. Like, we are not studying too much of security as yet, right, in networking portion, because first you need to understand networks. So at least 5 lectures extra, 5 hours extra I need to spend to. Already we have spent about 3 hours just to give you concepts. Okay, so I need 5 more hours at least. So you need to give me extra whatever slots, maybe, otherwise I will set it up on 6 to 7 any day. Is it okay?